Hi there, this is Weblan. Welcome back. With this one, I want us to look at functions in grade 10. And activity 1, we are given that g of x is equal to 3 over x minus 2. That's our function. And we are required to determine the equations of the asymptotes. Remember, an asymptote is that line which the function gets close to, but they don't or they never touch. So we've got two asymptotes for this hyperbola. Remember, the original hyperbola is in this form. That's our hyperbola. It has two parts, 1, 2, and the x-axis and the y-axis are the original asymptotes. The first one, the vertical asymptote, the vertical one will be the y-axis, and the equation of the y-axis is x is equal to 0. This is the equation of the y-axis, so that is our first asymptote. And then the horizontal asymptote, we get it from the value of q. Remember, this is g of x is equal to a over x plus q. So the horizontal asymptote, we get it from the value of q. So this one will be y is equal to -2. And this -2 also tells us that the function has been moved or has been shifted 2 steps downwards. And then the second question, question B, determine the equations of the axis of symmetry. For the hyperbola, we've got two equations, or we have got two lines of symmetry, or the axes of symmetry. The first one is this line which passes through the origin, and it has a positive gradient. The equation is y is equal to x. The equation is y is equal to x. That is the first one. And the second one is this one with equation y is equal to -x. So the two lines of symmetry meet at the origin. That is for the mother function. They have got equations y is equal to x and y is equal to -x. So we are saying here y is equal to x and y is equal to -x. These are the equations of the lines of symmetry for the original function. But the function in question at the moment has been moved 2 steps downwards. So it's a matter of saying -2 and -2. These are the two equations of the axis of symmetry, or the lines of symmetry. And then number C, sketch the graph of this function. We need a Cartesian plane, right? Here is our Cartesian plane. Now, for you to be able to sketch this graph, the first thing you are supposed to show the asymptotes. We said the first asymptote is the y-axis with the equation x is equal to 0, and the second asymptote is the horizontal one with the equation y is equal to -2. That is, it cuts the y-axis at -2. And then now, this is the original function with the horizontal axis at y is equal to 0. And if you look at this one, you can see that it does not have an intercept. But now, because of this negative 2, our function has been moved 2 steps downwards. So by moving it, it now has an intercept. Now to get this intercept, it's an x-intercept, and remember, for the x-intercept, y is equal to 0. So for our function, we are going to put 0 in place of y, and it's equal to 3 over x minus 2. We need the value of x here. So our 2 goes to the other side, is 2 is equal to 3 over x. The x goes to the left, 2 goes to the right. We have x is equal to 3 over 2, which is equal to 2,5. So we are saying here our function cuts the y-axis at 2,5. So it is somewhere here. This is where we have 0.2,5, 0 as to 2,5. And now we can draw our function. Our a in this case is positive, and when our a is positive, you should remember the 2 parts of the function, they are in the first quadrant and the third quadrant. So we are doing the same. The first part will be here, and then it goes there and it goes up, and the second part will be coming here. It goes down and it goes that side. So our function has got 2 parts. This is our function. G of x is equals to 3 over x minus 2. Remember to show the point, and you show the horizontal and the vertical asymptote. The next question is saying the values of x for which g is increasing or decreasing. Now, when you consider the issue of whether the function is decreasing or increasing, you look at the graph going from the left to the right. Now, from the left going to the right, our values of x are increasing. As the values of x are increasing, what is happening to the values of y? Remember, g, when we say g of x, it is in place of y, right? In functions, g of x is equal to y. In functions, we use g of x, but when you are dealing with equations general, we put a y. So we can say here the values of x for which y is increasing or decreasing. Let's look at what is happening to y as x is increasing. When x is increasing, y is going down slowly. So we are saying here, for the values of x before the y-axis, x is increasing, but y is decreasing, right? So we are saying here, this function, the left part of the function, is decreasing, right? So for the values of x less than 0, it is decreasing. How about the second part? From x is starting from 0. Remember, this is the asymptote going to the right. What is happening to the function? The function is starting up there, up towards infinity. As x is increasing, y, or the function, is decreasing. So it is also going down, right? So for that part, for the part where x is greater than 0, both of them are decreasing. So I want you to know that for the hyperbola, when a is positive, or when a is greater than 0, the function is a decreasing function. We see it now. Y is decreasing here. Even here it is decreasing. Of course, it has the limit, the horizontal axis. So it goes down, it decreases and continues to decrease, getting closer and closer to the horizontal asymptote, though we know it will never touch it, but it will still be decreasing. And the last question here, we want the domain and the range of G. Okay, are we done with this one? Okay, we are not yet done with this one. It is decreasing for x less than 0 and x greater than 0. So we are saying all the values of x except for the point where x is equal to 0. We can write this as x is an element of R, but x is not equal to 0, right? So all the values of x except for 0, the function will be decreasing. That's what we are talking about here. And then for the last question, question number E, domain. Remember, domain is x values. And our x values, they are starting from negative infinity going all the way to positive infinity. So we can take this one also as our domain, right? X is an element of R, but x is not equal to 0. This is the point where x is equal to 0. Remember, that's our vertical asymptote. And then range. Our range, it is the y values. And our y values, remember, they come from down there, negative infinity, going up all the way to positive infinity. So we can say y is an element of R. That is all the values of y, I mean all the numbers on the y-axis, they do satisfy our function, of course, except for the point where, the point where y is equal to -2. So this is -2. We are saying the domain, I mean the range for our function y is an element of R, but y is not equal to 2. So these are our asymptotes. X is equal to 0, that's our first asymptote up there, the vertical one, and y is equal to -2, that is the horizontal asymptote. That was activity 1. Let's look at activity 2. For our activity 2, we've got two functions here. The first function is a linear function, g of x is equal to -x minus 1. The second one is a quadratic function, which gives us a hyperbola, that is f of x is equal to -x squared plus 1. Now, what are we required to do with these two functions? The first question is saying determine the coordinates of A to E. We've got points A, point B, point C, point D, and point E here. The first ones that we want us to determine, question 1, is point A and point B. You should notice that point A and B are the x-intercepts of the parabola. And the x-intercepts of the parabola, they give us the solutions of the parabola where y is equal to 0. So we can rewrite this as 0 is equal to -x squared plus 1, where our y is equal to 0. So at point A, y is equal to 0, and point B, y is also equal to 0. That's why I have a 0 here. And then we solve the equation. This one goes to this side. It's x squared is equal to 1. And if we put square roots to both sides, x will be equal to plus or minus 1. So we are saying here, A is on the negative side, so A is -1. B is on the positive side, so it's +1. So our coordinates here For A is -1 as to 0, and for B is 1 as to 0. Remember, they are the x-intercepts, and then that was A and B, and then point C. Point C is our maximum for the parabola, and it is the y-intercept, right? For the y-intercept, x is equal to 0. So we can say here f of 0 is equal to -0 plus 1, which is equal to 1. So we are saying here point C is 0 as to 1. That is our point C. In other words, remember, this one is telling us that our function has been moved one step from 0 going upwards, right? So we have 1. And then from C, we are coming to D. All right, I want you to notice that we've got 2 points here, point A and point D. Our F and our G are meeting at A and also at D. So these two functions, F, they are equal at this point, point A and point D. So to find the coordinates of these 2 points is a matter of equating the two functions. So we have -x minus 1 is equal to -x squared plus 1. This is G and this is F. To solve this, we take this one to we take everything on the right to the left side. So we have x squared minus x minus 1 minus 1 is equal to 0. The 1 becomes negative and the negative here becomes positive. So we have x squared minus x minus 2 is equal to 0. And then we solve is equal to 0. 2 factors of -2, which when added they give a -1. X and x. The 2 factors is -2 and +1. And we know that is either this bracket is equal to 0 or that bracket is equal to 0. So from there we see that x is equal to +2 or -1. Remember, for A, we had a -1 already. So obviously, if A is -1, D is going to be +2, right? So for coordinates of D, we have the x coordinate. We need to find the y coordinate. Let's use G. So it's G of 2 is equal to -2 minus 1, which is equals to -3. So we are saying here the coordinates of D is 2 as to -3. The reason why I substituted this 2 into the G, is because D is also a coordinate along the function of G. So the point also satisfies that equation. So that is D. And the last one, E. The coordinates of E is our y-intercept of the function of G, right? And remember, G is in the form y is equal to mx plus c. G is in the form y is equal to mx plus c. So our m is -1, that is our gradient. Our c is also -1. So the coordinate of this one is 0 as to -1. We get it from the C. So we now have A, B, C, D, E. Let's go to the interesting part of the question. Question 2. All right. Question 2a is saying the values of x for which for which f of x is greater than 0. Remember, we agreed that f of x is y. This is function notation, and this is the notation that we use when we are just dealing with equations. So when we say the values of x for which f of x is greater than 0, we are talking about that area where y is greater than 0 or y is positive, right? When y is greater than 0 or positive, we are saying it's above the x-axis. So above the x-axis, y is positive. Below the x-axis, y is negative. So we want the values of x where f is positive or where f is above the x-axis. This is happening between a and b. From a going to the left, f is under the x-axis, or it is negative. From a to b, it is above the x-axis, so it is positive. From b going to the right, it is also negative. So these values of x that we are interested in, they are starting from -1. Remember, the coordinate of a is -1 as to 0, so it's -1 x to b is +1. So we are saying the values of x here is from -1 to +1. That is a, and then b, b is saying the values of x for which f of x is less or equal to 0. For this one, we want the part where f of x is under the x-axis. When we say f of x is less than 0, we are saying that part which is under the x-axis, right? So f is under the x-axis from a going to the left. So we can say where x is less than -1, right? But it is saying less or equal to. So x is less or equal to -1. Remember, when we solved here, we saw that x is also equal to -1. So is x is less or equal to -1. And then f of x is also negative, starting from b going to the right. So we can say x where x is greater or equal to 1. So we are saying f is under the x-axis, or f is negative or less than 0 from a going to the left and from b going to the right. We can put this together by saying x is an element of this from -infinity to -1, and also from +1 to going to +infinity. These brackets with corners are telling us that -1 is also included or is equal to x, and also +1 is included or is equal to x. That is b. And then c, our c, we are saying here g of x where g of x is greater than 0 or where g of x is above the x-axis. This is our g of x, and g of x is above the x-axis from a going to the left. So our x here is less than 0, right? So the values of g of x, the values of x for which g of x is greater than 0 or above the x-axis is x is less than 0. That is from not less than 0 is -1, right? So the values of x for which this is above the x-axis is from -1 going to the left. That is all the values of x less than -1. That is C. And then D, the more interesting one. Here we are comparing two functions here. So we want the values of x where f of x is greater or equal to g of x, or where f of x is above g of x. That's what this one means. Ne? So when we look at the two functions, we need that area where f of x is above g of x. This is our f of x and this is our g of x. F is above g, starting from A coming to D, right? So we can say f of x is greater than g of x, where x is between -1 less or equal to, remember it's saying less or equal to x, and less or equal to, what is the x coordinate of D? It's +2. So it comes down to 2. So we are saying f is above g between -1 and +2, right? We could write this as x is an element of this -1 to 2, and these cornered brackets are telling you that -1 is included in the list of values, +2 is also included in the list of values. And then the last one, this one is more interesting. This one is really interesting, and you should know when we say interesting, we are saying it's a little bit more challenging. So the more the challenge, the more interesting it is. F of x divided by g of x. That answer we get from dividing that should be negative, right? The values of x for which f of x over g of x is less than 0 or equal to 0. We are saying when we divide these two, we should get a negative. And when you divide two numbers and get, if you divide two numbers and then you get a negative number, it means one of the two is negative, right? So we want the parts of this where the other one is positive and the other one is negative, right? For this to be negative, it means either f of x is negative or g of x is negative. If we come from -infinity coming to a here, you'll see that g is positive, f is negative. So if we say f divided by g, we get a negative there. So we are saying x is less than -1. Remember, a is -1. And then from a, we want the part where the other one is negative and the other one is positive. Again, this happens between A and B. After B going to the right, both of them are now under the x-axis. So it means both of them are negative. So the part we are interested in only is between -1 to +1. That is between A and B. So we are saying x also is between -1 and +1. This is less or equal to. So this should be saying equals, right? Now, I want you to notice that the values that we are interested in, they are starting from -1, going to -1, and then passing -1, going to infinity, because we are saying x is less or equal to -1, right? So you can put this together simply by saying x is less or equal to +1. So we are saying the values of x that we are interested in are starting from -1 there at b, all the way going to the left. or going towards negative infinity. That's our functions. Continue to enjoy. Remember, practice makes perfect. You will eventually become perfect. Enjoy.